Hello, everyone. Mr. Minix, my name. Math is my game. And today, as with the last lesson, I am joined by my second period Algebra 2 class. And they're ecstatic to be here. In their group yesterday, while we were talking about number properties, I neglected to list these two. So we'll start off by talking about this identity property. The identity property. Not to be confused with the born identity. Not to be confused with Summerborn and the Summerborn identity. But anyway, the identity property says for all real numbers, if you take the number A and you add nothing to it, or you take nothing and add it to A, that you get just A. If you take A and multiply it by 1, or take 1 and multiply it by A, that you get just A for any real number A. Interesting fact about the number 0. 0 is called the additive identity. 0 is called the additive identity. Similarly, 1 is called the multiplicative identity. 0 is the additive identity, 1 is the multiplicative identity. That's a really hard word to write, pronounce. I don't even know if I spelled it right, probably not. I better write it out the right way. 1 is the multiplicative identity. Okay. That's really important. At some point this year, what we're going to do is we're going to add fractions. And adding fractions is way more difficult than multiplying them. And if you ever have to add fractions, you need a common denominator, and to get one, you need to understand how the multiplicative identity works. So that's the identity property, all right? There's one more property that I neglected to mention in my one class. It's called the inverse property. And it is related, it's cousins with the identity property. The inverse property says if you add the opposite of A to A, that you get the additive identity. Says if you multiply A by some weird number like this, that you get the multiplicative identity. So the opposite of A is A's additive inverse. 1 over A is A's multiplicative inverse. So these are the inverse properties. Okay, so negative A is the additive inverse, is the additive inverse. 1 over A is called the multiplicative inverse, is called the multiplicative inverse. A lot of I words, inverse, identity. And I do apologize for not mentioning those yesterday. And actually, while we're getting down to it, there's one more property that I forgot that most people love. I don't know why people love it so much, but everybody's good at it. It's that one that says if you have something and you multiply it by the group of the sum of something else, it goes like this. It says if you take A times B plus C, that you need to multiply A by B and add to that the product of A and C. Anybody remember the name of that one? Nice, good. The distributive property. The distributive or distributive property. The distributive property. And the interesting thing is, the distributive property is kind of like a wolf in sheep's clothing. And yes, I said wolf. Some people say wolf. My friend Tom, he says wolf. But anyway, have you guys ever done this? Were you ever asked to do this? To factor? We're going to be doing that in chapter 4. And factoring uses the distributive property, just in the inverted order. With factoring, you start with this kind of stuff. and you have to end with this kind of stuff, right? It's kind of interesting. Anybody know what we could factor out of 2x squared and 8x, what the greatest common factor we could factor out of that is? 2, we keep going. We could do a little better than just 2. 2, don't they both have an x in them? So we could factor out a 2x. So this would be 2x times x minus 4. Right? So anyway, keep that in mind. It's weird. Everybody's good at the distributive property the one way, but going the other way, it's kind of tricky, and that's factoring, and we'll be doing that in chapter 4. Okay. You know, I taught Algebra 2 for 12 years before I realized that factoring is just a distributive property. Crazy. All right. So, to be crystal clear on that quiz, there's going to be a question about the number properties. It says, which number property is related to the slope of a vertical line? Anybody know? Which number property is related to the slope of a vertical line? If not, we'll be answering that in the lesson once we get into lines. Which number property is related to the slope of a vertical line? I bet Mrs. Morgan has a little memory aid to help you remember that. We'll come back to that. So we got the inverse and identity properties taken care of. We need to talk about lines today, but before we do, there's one last thing that I didn't mention, and it's this idea of set notation. Set notation. One of my classes saw this. These symbols here are called braces. And braces are very often associated with set notation. So if you're ever asked to write out a set, you're going to need to include whatever's inside that set in those symbols. And I'll be real clear with an example. There's another kind of grouping symbol like this, and these, of course, are parentheses. Parentheses. And, of course, these are used with ordered pairs usually. Ordered pairs get closed up inside of those. And then there's one other kind, the kind that you might use to make shelves to hang some clothes on or something. What are these ones called? Brackets, sure. If you ever did the NCAA Final Four thing, brackets. In brackets, sometimes these things are used in conjunction, but brackets, really, there's only one thing that I've ever seen them used for in math other than in conjunction with these other ones, and they're used for the greatest integer function. And maybe we'll talk about that one day, but not today. But there's this thing called the greatest integer function. It's kind of weird. I don't think we have time to look at it. So make sure you know the difference between braces and brackets and parentheses, and make sure you know that if you're asked to put something into a set, anytime you hear or see the word set, that indicates that you have to have these thingies. So I told you I would give you a specific example. There's a question or two on the quiz that says, write out the set of whole numbers. Write out the set of whole numbers. So you probably are thinking to yourself, the whole numbers are all the positive integers plus one more number. What's the other one? 0, right. So the whole numbers are going to have a 1 in it and a 2 in it and a 3 in it. And it makes sense to put them in order, doesn't it? Okay. How would we separate them? With a comma, for sure. Now, it goes beyond 3. How do we indicate that it goes beyond 3? How many dots? 3, nice. And it's got to be 3. 2 doesn't mean the same thing, and 5 doesn't mean the same thing. It's got to be 3. Those are called the dots of ellipsis. That means it goes on forever and ever and ever. Now, we did say the number 0 is in here, and that's the smallest number in the set. Now, because it says set of, I'm missing something to close this group of numbers in. What do I need? Yeah. Got to have those braces. Nice. Good one on you. Got to have those braces. If you can't draw braces that well, don't feel bad. I can't either. Just make sure they're not brackets and not parentheses. Okay. Some people, including myself, are lousy at drawing these. Just do your best. Okay. So on tomorrow's quiz, you're going to be able to do that? Write out the set of whole numbers, just like that? Maybe we should look at integers, because integers is kind of a weird one. The set of integers would be dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. Okay, so that's what the set of integers would look like if you're asked to write those out. I feel bad about the heat, I really do. Every time it's this hot, it reminds me of the time I was at the circus. Did I tell you about that? I was at the circus, and we were under the big top, and somebody was smoking a cigarette, and they flicked it down on the ground. This was before the cigarettes had that stuff that made them go out. That's about the time I quit smoking, actually. But anyway, so this straw bale caught on fire, and there was a fire at the circus. Boy, the heat was intense. That was a bad joke. I shouldn't have told it. I'm sorry. See somebody thinking about it, like, oh, now it makes sense. Okay. Well, we need to talk about some lines. All kind of stuff about lines. This is basically chapter 2, sections 1, 2, 3, and 4. So we're skipping over all that information because you should have learned about this in geometry. I know for a fact that you did because I taught geometry last year. Well, I don't think one of you was in my geometry class a couple years ago. And then, so anyway, I know I teach this in geometry, but lines. First thing we want to talk about is slope. Slope is the measure of the steepness of a line. That's the definition of a slope. One of many, many definitions. Slope is the measure of the steepness of a line. Some of you are going to be taking the ACT. When I say ACT, I mean the academic something test, the academic college readiness test, the ACT. You know that one? If you plan on going to college, you're going to have to take that. If you're a junior, you're going to take it, and the school will pay for it, so you don't have to. So here's this question that shows up on that test. Bum, 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 bum. So we'll go ahead and call this line L and line M. Line L and line M. Everybody see what I got going on there? Now keep in mind, slope is the measure of the steepness of a line. The ACT asks this question. Which line has the greater slope? Question mark. Which line has the greater slope? Which line has the greater slope? Which line has the greater slope? I just want to go around the room, and I'm not going to put anybody on the spot. I won't name your names, but starting over here, what do you think? L or M? The blue one. So you're saying M. Okay. What do you think? M. What do you think? M. What do you think? M. What do you think? Go. Oh, we got one with L. Another one for L. One for M. Another one for M. Another one for M. L and M. Oh man. So let's go back to the drawing board and say another thing about slope. Maybe. I'm trying to go back on my smart board and it says, yeah, dog, we're not doing that. So there is a number associated with slope. M is the variable. We know M is calculated by taking the second y value, subtracting the first y value, dividing that by the second x value minus the first x value. Or maybe maybe y1 minus y2 over x1 minus x2. You could do either one. They only show you the one formula, but both of them are the same. But that's how you calculate the slope. And when you do, since it's a measure, since slope is a measure, it has a number attached to it, doesn't it? It has a number attached to it. So let's go back to this ACT question and see if maybe you changed your answer. So we see that the green line isn't very steep. The line M is clearly more steep, but the question doesn't ask us about steepness, even though it mentions slope, and slope is the measure of the steepness of a line. The question says which line has the greater slope. Let's go around and vote again. What do you think? We're going with L now. What do you think? L. What do you think? L. What do you think? L. What do you think? Still L? What do you think? L. What do you think? What do you think? L. What do you think? You got one for M? L and L. So this question is not intended to be a trick question, but it is intended to make you think. So you think, well, slope is how steep the line is. But then you've got to think, well, if I were to calculate the slope of this line L slope, the slope of line L is probably going to be something like 2/3, right? Maybe like 0.6, repeating. And the slope of line M, it's clearly steeper, but the slope of line M, that's weird, the M of M. The slope of line M is going to be negative something. It's probably going to be like -2. So what this question is really asking is which one of those numbers is greater, isn't it? Which one of those numbers is greater, -2 or positive 0.6? Positive 0.6. So line L has the greater slope. If the question said which line is steeper, then it would be line M. Does that make sense? It's kind of confusing, especially when it's 110 degrees in this room. Especially when we're thinking about the magical tractor. You guys remember about the magical tractor, right? Did you hear about the magical tractor? It turned into a field. It turned into a field. My jokes are really bad, I'm sorry. All right, so there's 4 different instances of slope for which you are responsible to know each of. Slope can be one of these 4 things. What color would you like these lines to be? Green? Red, 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 red. So sometimes lines do this, sometimes lines do this, sometimes they do this, and sometimes they do this. So in the first instance, when the line rises from left to right, what do we say about the slope there? Slope's positive. In math, in advanced math, we're going to say the slope is greater than 0. That's just a fancy shorthand way of saying the slope is positive. Okay? So you got to understand that there's lingo. Kind of like some people, when they talk to each other, they have a lingo. Like they say, yeah, yeah. That means, hey, how you doing? What's going on? That's what yeah, yeah means. Did you know that? And when you say greater than 0, you're just saying it's positive. Okay, what about when the line falls from left to right? What do you say about the slope? Less than 0. And again, that's the same thing as saying that the slope is negative. This is what I love about math. To me, math makes so much sense most of the time. Unlike the English language. The English language is weird, and I better not talk about it too much. But anyway, if the line is rising, it has a slope greater than 0. If the line's falling, it has a slope less than 0. What if the line goes straight across, somewhere in the middle? Somewhere in the middle of being positive and somewhere in the middle of being negative. The slope is 0, sure. So for horizontal lines, the slope is exactly equal to 0. Now there's two kinds of people in the world. Those who can make inferences from incomplete information, what do you guys think about this last one? Does anybody know what's up with it? It's undefined. How do we know that? Which number property tells us that? There's a number property. This is a quiz question on tomorrow. Division by 0. Nice. Who said that? Right on. You want me to shout you out? Shout out to Mr. Luke Porter. Nice job. Good one on you. So this would be like if we had the point 3,5 and then 3, -1. And we computed that slope. We'd say, okay, so the slope is 5 minus 1 divided by 3 minus 3. So that'd be 6 divided by 0. And we know what happens when you divide by 0. You have no friends. And it's undefined, right? Does anybody remember the memory aid that Mrs. Morgan used to talk about this? Yeah. Slope dude? Not slope dude. Good try, though. You ever hear of this thing? Vuxhoi means that vertical lines have a slope that's undefined. The line itself's not undefined, but its slope is. And x equals some number is the equation of it, right? So the first thing says this kind of line. The second thing says this is the deal with its slope. The third thing says this is the deal with its equation. So it says horizontal lines have a slope of, that's Z-E-R-O, a slope of 0. And y equals some number is the equation. Okay. So that's what that Vuxhoi was all about. Slope dude was kind of cool. I like block dude too. That was a game on my calculator. So speaking of lines, we probably ought to dive right into this. We're going to be doing a lot with graphing this year in this class. A lot more than you did in geometry, that's for sure. So you're going to be given something that looks like these. Looks like that. And you're going to be asked to write the equation of the line. Write the equation of the line. What kind of line is that? Horizontal line. What's the equation of a horizontal line? The slope is 0. What's the equation? Vuxhoi tells us. Y equals some number. What number? -4. Dude, that's like a gimme. That's like a layup. That's like walking down the sidewalk and seeing a 20 spot. Wouldn't that be the coolest thing, just walking down the sidewalk and you see a 20? What are you going to do? Give it to the nearest person, or are you putting it in your pocket? Heck yeah, dog. That's my 20. Okay. What if we had this line? What's the equation of that line? x equals 2. Those should be layups. Those should be really easy to do, right? All day. If you know Voxoi, if you get it. Well, do 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 do. I don't know why I'm in a do kind of mood today. Anybody else in a do kind of mood today? Okay, so just a couple of reference points here. Whoop. Write the equation of this line. So there's a tool that we need to know. We need to know that form, that one form that everybody on planet Earth knows about lines. It's called slope hyphen intercept form, and everybody knows it, right? What's it look like? Y equals mx plus b. Now there's a reason that I put the m in red and the b in red, because the y is going to stay y, the equals is going to stay equals, the x is going to stay x, and we're going to be replacing m and b with numbers, right? The slope's going to take the place of m. So if we look at this line, we'd need to find the slope. We know the slope is how steep the thing is. So it looks like we go down 1 and over 1, and down 1 and over 1, and down 1 and over 1, and down 1 and over 1. What's the slope of this thing? -1. And the y-intercept is the b. The b is the y-intercept. The y-intercept is, in case you don't know, it's the value of y when x equals 0. Or it's where the line crosses the which axis? The y-axis. So what is the y-intercept of this thing? -8. So the y-intercept of this particular line is -8. So then when we go to write this, our answer would be what? Y equals negative. Should we write the 1 or shouldn't we write the 1? Just -x, right? If we wrote the 1, it's not wrong, but this is varsity math, so y equals -x, and then what? -8. There we go. So if we're given the graph, and we can easily compute the slope, that's not bad, right? Well, sometimes I rhyme slow, and sometimes I rhyme quick. I was on 125 in St. Nick, waiting on a cab. She got the best of me. What was my destiny? Sometimes we're not going to know those things. Sometimes all we're going to be given is 2 points. Find the equation of the line that passes through T-H-R-O-U-G-H, or just a U? 3, 5, and -6, -9. So when you have something like this, I'm a firm believer that a picture is worth 1,000 words. You ever hear that saying? So I like to at least sketch this to see what I'm looking at. -6, -9. So there's point Q, I'll call it. -6, -9. Point P goes through 3, 5. 3, 5. I hope everybody knows how to plot points. Everybody remember that, the x-coordinate, y-coordinate thing? Okay. So just looking at those 2 points, recalling the very first or second or third postulate from geometry, through any 2 points there's one line, right? So we know that the line goes through those 2 points. We learned that in geometry. So let's think about that line. Is its slope going to be positive or negative? Its slope's going to be positive, right? So we know that our answer is going to look something like this. Y equals some positive number x. And what about our y-intercept? Do we have any idea? Can we tell for sure what it is? It looks like 0, but do we know for sure it's 0? No. Who knows? I don't know. So the deal is I gotta go ahead and calculate or compute both of these things, the y-intercept and the slope. Oh, man, that's going to be fun. So without being able to do any work, I could say, well, y equals something times x plus or minus something. So here, let's go ahead and compute the slope. The slope's going to be, what do you want to start with, the 5 or the negative 9? 5. So 5 what? Minus 9 divided by what minus what? 3 minus 6. So what happens when we minus 9 from 5? What do we get? Addition. So that's plus, so that's going to be 14. And then what do we get in the bottom? Oh, man. That's going to be 14 divided by 9. Do you know what math class this is? Algebra 2. Have you heard me say it's varsity math? It's varsity math. 14 divided by 9, there's nothing wrong with that number. It's an improper fraction. It's okay. It's okay. Of course, that's 1 5/9. That's 1.55555555555 repeating. 14/9 is okay. Get in the habit of having improper fractions. I know you hate them. Studies have shown that 5 out of 4 Americans struggle with fractions. It's okay to have a fraction for an answer. So y equals 14/9 x. Now we got to find that stinking y-intercept. Oh, man. The only other thing we know in the universe is that y equals mx plus b. Does anybody see a way that we could maybe compute the b value, given all the other information? I bet Miss Dempsey would know. I bet little Mrs. Fisher would know. You guys know little Mrs. Fisher, right? And Miss Dempsey, what do they do? And Mrs. Rose? Substitute. So what do we want to replace y with? Take your pick, 5 or negative 9. Okay, so instead of y, we're going to have 5 equals m. Do we know what m is? Yeah, it's 14/9. Oh gosh, fractions. Oh, dang it. 14/9 times x. It's a good thing we picked the 3, 5, because that's going to work out nice. So times x times 3, that's 3 over 1, plus b. Okay. All right. Well, this isn't going to be that bad. So when we look at this particular calculation, do you guys know how to cross-cancel? You familiar with cross-canceling? Cross-canceling says because there's a 3 and a 9, I could cross-cancel this 3 and the 9, because 3 and 9 are both divisible by 3, right? The 3 is going to turn into a 1, the 9 is going to turn into a 3, and the magical tractor turned into a field. So now what I've got going on here is 14 times 1 in the top. What's 14 times 1? That's going to be 14. And in the bottom, I've got 3 times 1, which is that 3? Okay, so 5 equals 14/3 plus b. You with me so far? Okay. Now, Houston, I have a problem. 5 is written as a whole number, and 14/3 is written as a fraction in terms of thirds. Wouldn't it be nice if I could change 5 into a certain number of thirds? Oh, I can, if I understand the multiplicative identity. I'm going to multiply 5 by the number 1, but it's not going to look like the number 1. It's going to look like the number 3 over 3. So 5 is really how many thirds? 5 is really how many thirds? Somebody said it? Nice, 15/3. So this whole thing is going to become 15/3 equals 14/3 plus b. Now I want to get the b all by itself, so what do I do now? Bueller. I want to get the b by itself, so what should I do with this 14/3? Subtract it from both sides, minus 14/3. Minus 14/3. If I have 15/3 and I take away 14/3, how many thirds is left? 1/3. So b ends up being 1/3. B ends up being 1/3. I know that was a lot of work. I know our y-intercept looked like 0. It was close to 0, but it wasn't 0. It was 1. Whoop, it was 1/3. 1/3. I know that was tough. That's the toughest ones they're going to get with these. What do you think? Well, we got a couple more things. We're getting there. I hope everybody does good on tomorrow's quiz. Write the equation of the line parallel to y equals negative 3x plus 4 that passes through the point negative 8, negative 2. Woo! There's a buzzword here, parallel. What do you know about parallel lines and their slopes? Not opposites. The slopes of parallel lines are the same. So the slope of the line that we're trying to find is going to be the same as the line that they tell us about. So what's the slope that we're going to be working with? Negative 3. So that's the slope. We already know our slope. And they give us a particular x value and a particular y value. So once again, we could go back and substitute into that y equals mx plus b, right? So using y equals mx plus b, we could say, okay, y is negative 2, so negative 2 is slope, which is negative 3, times x, which is negative 8, plus b. So b equals negative 26. Right? Did I skip too many steps? So what's our answer then? Our answer would be y equals how many x? Negative 3x, and then what? Minus 26. And there it is. I know it's been a long day. I know it's hot. We only have one last thing to talk about, and those are the different forms. The different forms. We saw this one, y equals mx plus b. Of course, that's called slope hyphen intercept. We saw this one, x equals some number. That's what form is that? What kind of line? Good try, not horizontal. The slope's undefined, but the type of line it is a vuxoid, vertical, right? Vertical line. Y equals a number then, that's going to be a horizontal line. There's this other form that I kind of like. It says y minus the first y equals m times the group x minus the first x. Anybody remember the name of that one? If you could imagine, if you could picture dividing both sides by x minus x1, doesn't that kind of look like the slope formula? This is actually called point slope form. This is called point slope form. It's really handy, really useful. And there's one more form, and this is it for the day. The last form of the equation of a line, ax plus by equals c. Anybody remember the name of that one? You don't want to get the abbreviation to it, I'll tell you that. Standard form. Maybe I better not abbreviate it. Standard form. Standard form. A couple things about standard form, and then this is it. I know I said this is it. We're done. With standard form, A has to be positive. A, B, and C should be integers. Otherwise, you can have an infinite number of answers. And also, A, B, and C should be integers that are relatively prime. That are relatively prime. And we'll talk about that some other day, not today. So ax plus by equals c, where a is positive, a, b, and c are integers, and a, b, and c are all relatively prime. So what I'm saying is if you had something like negative 6x minus 3y equals 12, does that meet the criteria? No, it doesn't, because the leading coefficient's got to be positive. So you might say, okay, well, let me make this positive 6x plus 3y, and that's equal to negative 12. Well, we're getting closer, but you know the problem with all those coefficients? 6, 3, and 12? They're not relatively prime because you can divide them all by which number? You could divide them all by 3. So if you divided them all by 3, that would make this 2x plus y equals negative 4. That would meet those criteria. Okay, if that kind of went over your head, don't sweat it. But that's what standard form is going to look like. The leading coefficient's positive. The coefficients are relatively prime. It's been real. It's been fun. Anybody want to give a shout out? I'm going to give a shout out to the future Mr. Minnick for being such a nice guy. Have a great day. Good.